The solar system is an amazing system with many interesting planets, moons, dwarf planets, and much more. Today, I'll be explaining the basics of these amazing celestial objects in our own star system. Enjoy! The celestial bodies of our solar system. Let's start off with introducing the celestial bodies that are in our solar system. Firstly, we have the larger ones, such as the planets. There are 8 planets in our solar system, which are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Planets are celestial objects that orbit a star, have enough gravity to become a ball, and have cleared their orbits from annoying asteroids or other planets. They are categorized into 3 groups: the terrestrial planets, the gas giants, and ice giants. Next, we have the moons that orbit those planets. A moon is a natural satellite of a celestial body, like a planet or dwarf planet. Next are the dwarf planets. Dwarf planets are smaller versions of planets that are too big to be considered asteroids, but too small to count as planets. They are objects that have yet to clear their orbit from smaller objects like asteroids, comets, or even other dwarf planets. And lastly, we have the asteroids and comets. They are debris left over from the formation of the solar system that didn't become big enough to be planets or dwarf planets. Now that we've introduced the objects I'll be explaining today, let's get to know them! The Sun. Let's start off with the center of our solar system, the Sun. The Sun is a G-type main-sequence star and is the center of our solar system. The Sun is mainly made of hydrogen and helium, with some trace elements in a plasma state. It has a diameter of 1,391,400 kilometers, or about 109 times the diameter of Earth. The Sun contains 99.8% the mass of the entire solar system. For comparison, Jupiter, the most massive planet in our solar system, only represents 0.1% of the mass of the entire solar system. It has a surface temperature of over 5,700 Kelvin and is powered by nuclear fusion happening in its core. Due to the Sun's immense power, all the planets in the solar system are able to receive light and warmth. The Sun isn't always kind to us though. Sometimes it releases powerful bursts of intense high-energy radiation and charged particles known as solar flares. But we all have to thank the Sun for keeping all the planets together with its powerful gravity. Mercury. Mercury is the first planet in the solar system and is the closest planet to the Sun. Mercury's diameter is only 4,879 kilometers, making it the smallest planet in the solar system. It is made of 70% metallic stuff and 30% silicates, making it the second most dense planet in the solar system, after Earth. Mercury is the most cratered planet in the solar system. Its surface is completely covered in craters. Since Mercury barely has an atmosphere, any craters that form will not erode away over time. Another effect of having no atmosphere is that the day and night side of Mercury has a drastic temperature difference. The day side can reach temperatures of up to 430 degrees Celsius. Meanwhile, the night side can reach temperatures of negative 180 degrees Celsius. Mercury orbits the Sun at a distance of around 0.4 AU, or 57.9 million kilometers. With such a small orbit, it only takes 88 days to revolve around the Sun once. Meanwhile, it takes 59 days to rotate once. It has no moons. Venus. Venus is the next planet to the Sun. Despite it being the second planet to the Sun, Venus is actually the hottest planet in our solar system. This is due to Venus having a thick atmosphere that traps heat, one that is over 90 times thicker than Earth's. Venus has a diameter of 12,104 kilometers, which is about the same size as Earth. Venus orbits the Sun at around 0.72 AU, or 108 million kilometers. It takes Venus 243 Earth days to rotate once on its axis, meanwhile taking 225 Earth days to orbit the Sun once. Also, Venus spins in the opposite way of every other planet's spin. Venus is sometimes called Earth's twin sister for a couple of reasons. Firstly, they both have roughly the same size, density, mass, and gravity. Secondly, Venus and Earth formed in the same inner region of the solar system, and they're all mainly composed of the same stuff. And third, they both have weather and rain. But the similarities end there. Because, unlike Earth, Venus is basically hell. It has a temperature of over 460 degrees Celsius, hot enough to melt lead. That thick atmosphere that makes the planet extremely hot is made of toxic carbon dioxide and is also very dense and heavy, making the atmospheric pressure there 92 times what we would feel on Earth at sea level, which would also immediately crush you or any spacecraft would try landing there. Also, the rain I mentioned earlier isn't made of water. It's made of very hot and acidic sulfuric acid. So yeah, Venus is basically hell. Don't visit her. Venus is also known to have volcanoes. Tons of them. Over 1,600 major volcanoes or volcanic features that are known, and possibly over 100,000 smaller ones. Venus has no moons. Earth. The third planet from the Sun is Earth, our beautiful home. Earth has a diameter of 12,742 kilometers. 1 year on Earth, unsurprisingly, lasts 1 year, or 365 days. And 1 day on Earth lasts 23 hours and 56 minutes, which we rounded up to 24 hours. Earth's semi-major axis is 1 astronomical unit, or around 150 million kilometers. It has a pretty thick atmosphere that we can breathe and oceans that cover over 70% of its surface. Earth also has something no other planet has: life. Earth is the only planet in the universe that we know has life so far. Around the time the oceans formed, which was 4.4 billion to 3.8 billion years ago, the first life forms emerged. Earth also still has a warm interior, which is pretty rare among other rocky planets in our solar system. This warm interior is what generates the strong magnetic field that protects us from solar winds, and the plate tectonics that keep on renewing the surface of the Earth, makes volcanoes, and shapes the surface of the Earth. Earth has one moon named the Moon, or Luna. Luna has a diameter of 3,475 kilometers and orbits Earth at a distance of 384,400 kilometers every 27.3 days. Luna was born from a collision between the Earth and another object around half its size that happened 4.5 billion years ago in the early solar system. Luna is responsible for making our tides, maintaining our stable axial tilt, and 24-hour long days. Luna also has these darker spots on her known as seas. They are believed to have been ancient seas of lava from her formation that have long since cooled off and became smooth basalt. Another fun fact about Luna is that she's slowly drifting away from us at a rate of 1.5 inches or 3.78 centimeters per year. But don't worry, unlike what I said in my other video, she won't slowly abandon us in 5 billion years, leaving us moonless forever. Instead, she will stick around with the Earth until the Sun dies, or will get consumed by the red giant Sun along with Earth. True besties stick together until the end. Mars. The planet after Earth is Mars, the fourth planet from the Sun. Mars has a diameter of 6,779 kilometers, around half of Earth's. It orbits the Sun at a distance of 1.5 astronomical units, or 228 million kilometers. Mars is often called the red planet for appearing reddish in color from a distance. But from a closer view, Mars is actually more of a butterscotch color. This color is due to rusty atmospheric dust and the Martian regolith that is made of rust. A Martian day is similar to an Earth day, lasting 24 hours and 37 minutes. Meanwhile, a Martian year lasts 687 Earth days, or roughly 670 Mars days. Mars is believed to have once had a huge ocean of water, just like Earth in the past. But around 4.1 billion years ago, Mars's interior cooled down too much, and its magnetic field died. Once its magnetic field died, the powerful solar winds blasted away Mars's atmosphere and water, leaving it desolate and barren. Mars has two moons named Phobos and Deimos. Their origins are unknown, but we have some good guesses. The first theory says that they're both captured asteroids that were flown from the asteroid belt by Jupiter and captured by Mars around 1 to 2.7 billion years ago. The second theory says that they are debris left over from forming Mars that remained in orbit and slowly accreted over time. The third theory says that they are remains of a larger moon that once orbited Mars. Phobos orbits 9,377 kilometers from Mars, meanwhile Deimos orbits 23,460 kilometers from Mars. Asteroids and the asteroid belt. Asteroids are the debris left over from forming the planets. Most asteroids are found in the asteroid belt, but they can be found anywhere in the solar system, even on Earth-crossing paths. Usually, asteroids are relatively small objects, but some can be hundreds or even 1,000 kilometers in diameter. For example, Ceres, Vesta, Pallas, and Hygeia. But thankfully, most of them are only a couple tens of kilometers in diameter, and those ones rarely cross Earth. Most near-Earth asteroids are only a couple hundreds of meters. A common misconception about asteroids is that they're in these densely packed fields of asteroids, but in reality, they're usually over 900,000 kilometers apart from each other. Another misconception about asteroids is that they're solid rocks, but in actuality, the smaller ones usually have a surface of loosely held together gravel that feels more like those ball pits you can find in playgrounds. The larger ones are usually solid though. Also, some asteroids can have moons. For example, Ida. Ida is a large asteroid in the asteroid belt that has a little moon orbiting around it named Dactyl. Another example is Didymos. Didymos has a moon named Dimorphos. You may know Dimorphos as the target of the DART mission as they did a couple years ago. One asteroid decided that moons wasn't enough and decided to get pretty rings. Chariklo is a centaur with a diameter of approximately 250 kilometers. The ring system is pretty bright and consists of two narrow bands separated by a relatively small gap. The origin of the rings is still unknown, but there are some pretty good theories, like an impact on Chariklo, a collision between pre-existing moons, or even material released from Chariklo's icy surface. Some asteroids are unlucky enough to become moons of massive gas giants by getting gravitationally captured. Ceres. Ceres is the first dwarf planet from the Sun. It orbits in the asteroid belt with an average distance from the Sun of 2.8 AU or 413 million kilometers. Ceres is the largest and most massive object in the asteroid belt, making up about a third of the mass of the entire asteroid belt it lives in, and having a diameter of a little under 1,000 kilometers. It takes Ceres 4.6 years to orbit the Sun and 9 hours to complete a rotation. Ceres is made of a quarter water ice and 3/4 rocky material, and some yummy salt I'd like to eat. Ceres is thought to have cryovolcanoes and grows a new one every 50 million years on average. Ceres was actually thought to be a planet back in the 1800s when it was discovered. Ceres was finally reclassified as an asteroid in 1851, along with the other bodies they found in the belt. Then, in 2006, Ceres was reclassified again to be a dwarf planet along with the other dwarf planets that we know today. Ceres doesn't have a moon. Jupiter. Jupiter is the fifth planet in the solar system. It is the largest and most massive planet in the solar system. Jupiter has a mass of 318 Earth masses, which is 2.5 times more than all the other planets in the solar system combined, and has a diameter of 139,820 kilometers, which is 11 times more than Earth's diameter. Jupiter orbits the Sun at a distance of 5.2 astronomical units or 778 million kilometers. Despite being the largest planet, Jupiter actually spins the fastest, completing one rotation in just 10 hours, but taking under 12 years to orbit the Sun once. Jupiter is a gas giant because it's made of mostly hydrogen and helium, which means there isn't a surface on Jupiter. Jupiter's atmosphere is separated into different bands with different colors due to the different chemical composition and temperature of the gases in each band. Jupiter also has a very notable feature, which is the Great Red Spot. The Great Red Spot is a giant storm on Jupiter. It has a beautiful red-orange color and has wind speeds of over 400 kilometers per hour. Jupiter also has amazing and bright auroras. This is thanks to its very powerful magnetic field, the second most powerful in the solar system, only beaten by the Sun's. Jupiter has 95 moons, but let's only talk about the 4 major ones to shorten this video. The 4 large moons of Jupiter are Io, Europa, Ganymede, and Callisto. The first of Jupiter's major moons is Io. Io is covered in volcanoes and holds the record for the most volcanic object in the solar system. All this volcanism is due to tidal forces exerted on it by Jupiter and the other moons. The next moon is Europa. Europa is the smallest of the 4 major moons of Jupiter. It has a crust made of water ice and is believed to have a mantle of liquid water. Europa's subsurface ocean is thought to have more water than all of Earth's oceans combined. This ocean is believed to be kept warm by tidal forces from Jupiter and the other moons, plus some extra heat from Europa's interior. Next up is Ganymede, the largest moon of Jupiter and the largest moon in the entire solar system. Ganymede is even larger than the planet Mercury. Ganymede is mainly made of water in a solid state, but some of that ice is also liquid hidden underground. Amazingly, some of this ice isn't the normal ice we can find here on Earth. Instead, they would be exotic ice. The moon after that is Callisto. Callisto is the farthest out major moon of Jupiter and is geologically dead. It is also covered in craters and ejecta from asteroid impacts that have accumulated over billions of years. The other moons of Jupiter are nothing but captured asteroids plus some large rocks orbiting close that may have accumulated from ring particles. Saturn. The 6th planet in the solar system is Saturn. Saturn is the 2nd largest planet in the solar system with an average diameter of 120,500 kilometers. Saturn is also the 2nd most massive planet in the solar system, having 95 Earth masses. Despite being so massive, Saturn has a very low density, one lower than water, making it the least dense planet in the solar system. This is due to Saturn being a gas giant that's mainly composed of light gases such as hydrogen and helium. Saturn orbits the Sun at a distance of 9.6 astronomical units, or 1.4 billion kilometers. It takes Saturn 29.4 Earth years to orbit the Sun once, meanwhile taking just under 11 hours to spin once. This fast rotation and how light Saturn is makes the equator bulge a lot. enough to be noticeable from space. Saturn has pretty rings and is often recognized for them. Unlike what some people think, these rings aren't actually a solid disk that you can walk on. Instead, the rings are made of particles of water ice and some dust. Saturn has the most moons out of all the planets, 146 of them to be exact. I'm only going to be talking about the major ones since I don't want this video to last several hours. The major moons of Saturn are Mimas, Enceladus, Tethys, Dione, Rhea, Titan, and Iapetus. Let's start with the first major moon of Saturn, Mimas. Mimas is a small moon that's only around 400 kilometers in diameter. It is mainly composed of ice and is covered in craters. One of these craters, known as Herschel crater, is so big that it covers a huge portion of Mimas' surface. It also makes Mimas look like the Death Star. Next is Enceladus. Enceladus is another small and icy moon of Saturn. It has a crust made of ice and has some cracks and craters. Under that icy crust is a subsurface underground ocean, just like Europa's. The jets of water erupting from Enceladus' south pole serves as even more evidence of a subsurface underground ocean on Enceladus. After Enceladus is Tethys. Tethys is another very icy moon, being almost completely composed of water ice. Tethys has the lowest density of any major moon in the solar system, at only 0.98 grams per cubic centimeter. Tethys is heavily cratered, one crater being around 400 kilometers in diameter. Tethys also has a slight difference in color from its leading hemisphere and its trailing hemisphere. Next up is Dione. Dione is an icy world, just like Tethys. Its trailing hemisphere is marked by large cliffs. Dione has a crust and a mantle made of mainly water ice and a core made of rock. After Dione is Rhea. Rhea is the second largest moon of Saturn. Rhea is made of 3/4 ice and 1/4 rock. It is also believed to have a tenuous ring system, but that's still kind of up for debate. Also, Rhea has a thin atmosphere made of oxygen and carbon dioxide. After Rhea is the largest and most popular moon of Saturn, Titan. Titan is the second largest moon in the solar system, coming in at 5,150 kilometers wide, and is still larger than Mercury. Titan is special for being the only moon in the solar system to have a thick atmosphere, one that is 20% more massive than Earth's, and mainly made of nitrogen and methane. Titan also has lakes of ethane and methane on its north pole and shows sign of possible cryovolcanism. And like some other icy moons, Titan is also thought to have an underground ocean under its icy crust. The last major moon of Saturn is Iapetus. Iapetus is the third largest moon of Saturn and is also made of mostly ice. Iapetus also has a strangely inclined orbit that's beyond all the other moons' orbits. It is known for its striking double-colored appearance, with one side being white as snow and the other being as dark as coal. All the other moons of Saturn are either captured asteroids or oversized ring particles. Uranus. Uranus is the seventh planet in the solar system and is the third largest. It has a diameter of 51,120 kilometers. Uranus is an ice giant, meaning it's mainly composed of a dense fluid of cold water and ammonia, mixed in with some methane ice floating above a rocky core in the center of a thick atmosphere of hydrogen and helium with some methane. Uranus orbits the Sun with an average distance of 19 AU, or 2.9 billion kilometers. It takes Uranus 84 years to orbit the Sun once, but only taking 17 hours to spin once. Despite being only the second farthest out from the Sun, Uranus is actually the coldest planet in the solar system. Uranus has a beautiful pale cyan color because of the methane ice particles in its clouds. It also has a strange axial tilt which is over 90 degrees, which makes it seem like it's spinning sideways. Like the other gaseous planets, Uranus also has rings and a ton of moons. What's cool is that even its rings and major moons follow this sideways tilt. Uranus has 28 moons to be exact. Only 5 of these 28 moons are the large major ones. The others are just captured asteroids or shepherd moons. The 5 major moons of Uranus are Miranda, Ariel, Umbriel, Titania, and Oberon. Starting off with Miranda, it is the smallest and closest major moon of Uranus. Miranda is only just under 500 kilometers in diameter. It has giant fault canyons as much as 12 times deeper than the Grand Canyon, terraced layers, and a mix of old and young surfaces. Miranda is the least dense of the Uranian moons, with a density of only 1.15 grams per cubic centimeter, which means that Miranda is mainly made of ice and less rocky stuff compared to the other moons. The next moon is Ariel. Ariel is the brightest moon of Uranus and has a very cratered surface, along with long rift valleys stretching almost the entire surface. Ariel also seems to have the youngest surface out of all the moons of Uranus. It is made of roughly equal amounts of water ice and silicate rocks, like all the other moons of Uranus. After that is Umbriel, the darkest of Uranus's largest moons. Umbriel only reflects 16% of the light that hits it. It also has a heavily cratered surface, which might mean that Umbriel has one of the oldest surfaces in the Uranian system. Umbriel isn't all dark though. It has a strangely white crater called Wanda crater on its equator. The moon after that is Titania. Titania is the largest moon of Uranus. Titania is believed to once have been geologically active in the past. Titania is also believed to have a very salty or briny ocean underneath its icy crust, just like some of the other moons of Uranus. The last major moon is Oberon. Oberon is the second largest major moon of Uranus, after Titania. It is the most cratered moon in Uranus' system. This highly cratered surface means that Oberon might have the oldest surface out of every moon in the Uranian system. Neptune. The final planet to the Sun is Neptune. Neptune is another ice giant, just like its sister planet Uranus. Neptune is the farthest out planet from the Sun, orbiting at roughly 30 astronomical units, or 4.5 billion kilometers. Such a huge orbit takes a long time to complete, around 165 years to complete. But Neptune only takes 16 hours to spin once. Neptune is a very stormy planet. Wind speeds there can reach up to 2,200 kilometers per hour. That's almost twice the speed of sound here on Earth. Neptune actually has a cyan color, just like its sister Uranus. Neptune also has quite a lot of moons, 16 to be exact. It also has some rings too, though they are a little hard to see. Neptune only has one major moon. All the other major moons seem to have just gone missing. Triton is the only major moon of Neptune. It is 30 to 45% made of water ice, with the rest of it being rocks and possibly metal core. Triton is 40% larger than the largest dwarf planet, Pluto. Triton is also pretty special in the way it orbits its parent planet. All major moons orbit their planet in a prograde motion and along their planet's equator, except for the previously mentioned Iapetus and Triton. Triton's orbit is inclined by 157 degrees from Neptune's orbital plane. An inclination over 90 means a retrograde orbit, by the way. All this indicates that Triton might be a captured dwarf planet that Neptune captured from the Kuiper Belt. Triton also has a similar composition to that of Pluto, which only serves as more proof that they share a common origin in the Kuiper Belt. Because it is slightly larger than Pluto, Triton actually used to be the largest dwarf planet in the Kuiper Belt. The Triton capture theory also explains why Neptune doesn't have any other major moons today. Triton's capture must have disrupted their orbits so much that they either crashed into Neptune, got ejected into the Kuiper Belt, or crashed with each other to form Neptune's smaller moons. All the other moons of Neptune are nothing but captured asteroids or small non-rounded bodies orbiting close to Neptune. The Kuiper Belt. After Neptune, we have a region in the solar system known as the Kuiper Belt. The Kuiper Belt is a donut-shaped region beyond the orbit of Neptune that extends from 30 astronomical units to 50 astronomical units. Like the asteroid belt, the Kuiper Belt consists of small bodies and remnants from the formation of the solar system. But, unlike objects in the asteroid belt, objects in the Kuiper Belt are made up of mostly ices and volatile stuff. It is also the home to most of the dwarf planets we know and love, and some pretty comets too. Let's just talk about the 8 largest and most well-known dwarf planets in the Kuiper Belt. Pluto. Pluto is the most well-known of the dwarf planets. It is the largest trans-Neptunian object and the second most massive, only beaten by Eris. Pluto's orbit in the Kuiper Belt is about 39 astronomical units, or 5.9 billion kilometers away from the Sun on average. It has an orbital period of 248 years, but it only takes 6.4 Earth days to spin once on its axis. Pluto is extremely cold. It has a surface temperature of only negative 232 degrees Celsius. Like Uranus, Pluto spins in a strange way, with an axial tilt of 120 degrees. Like the other objects in the Kuiper Belt, Pluto is mainly composed of water ice and rocky stuff. Pluto was discovered by Clyde Tombaugh in the year 1930. Back then, Pluto was thought to have been the ninth planet, but we all know how that turned out. Most of us remember Pluto as that one demoted planet, but it has way more interesting things about it than just being a failed planet. Pluto has a surface covered in nitrogen, ice, and snow, along with some traces of methane and carbon monoxide. The mountains on Pluto are made of solid water ice that behaves like granite because of how cold it is there. Most of the surface of Pluto is covered in nitrogen snow, like I said before, but in some regions of Pluto's surface, the ground can be covered in a reddish snow-like stuff called tholins. Tholins are organic compounds formed from ultraviolet light from the sun hitting simple carbon-containing molecules. Pluto also has a tenuous atmosphere made of nitrogen, methane, and carbon monoxide. A very sweet thing about Pluto is that it has a huge heart called Tombaugh Regio, named after the person who discovered Pluto. Tombaugh Regio is often nicknamed Pluto's heart after its shape. It is the largest bright surface feature on Pluto, being about 1,590 kilometers across. It is speculated to have been the result of a huge impact that was filled with nitrogen ice. A part of the surface of Tombaugh Regio is divided into polygonal cells that are actually convection cells that are only a few million years old. This means that Pluto is still geologically active. Another thing that proves Pluto is still geologically active is the cryovolcanoes it has. Pluto is believed to have an underground ocean. Pluto has 5 moons. They are Charon, Styx, Nix, Kerberos, and Hydra. Charon, the largest of the moons, isn't actually a moon, but more of a binary companion, since Charon is so massive compared to Pluto. They actually both orbit a point called the barycenter that is outside of both bodies. Charon is so large that it and Pluto are tidally locked to each other, meaning they always show the same face to each other. A really cute thing about this tidal locking is that Pluto always hides its heart-shaped crater from Charon. Charon is made of roughly half water ice and half rock. Pluto and Charon is believed to have been brought together by a kiss-and-capture collision 4.5 billion years ago, similar to the Earth and Moon. Charon also has a reddish-colored cap on its north pole. This formation is believed to be formed from Charon stealing methane from Pluto's atmosphere that slowly turned into tholins over time from solar radiation. The other 4 moons of Pluto orbit the barycenter of Pluto and Charon and are nothing more than small, irregular asteroids formed from the same collision that made Pluto and Charon. Haumea. Haumea is the next dwarf planet we'll be talking about. It is the 3rd largest dwarf planet at about 1,600 kilometers on average. Haumea orbits at around 43 astronomical units or 6.5 billion kilometers away from the Sun on average. Haumea is also special for having a silly egg-like shape. Haumea is the fastest spinning dwarf planet, taking only under 4 hours to spin once. This fast rotation is why Haumea has its silly egg shape. Astronomers were able to find out about its fast spin because of a darker spot on Haumea's surface that is thought to have been a tholin deposit. Haumea is made of mostly rock covered in a relatively thin layer of water ice. Haumea is also known for having a thin ring system. This ring system is only about 70 kilometers in width and is probably made of ice. Haumea has 2 moons. They are Hayaka and Namaka. Namaka is the closer moon to Haumea and is the smaller one of the two, at only about 170 kilometers in diameter. Hayaka is the largest one of the two, and is roughly 470 kilometers in diameter on its longest axis. They are both probably just irregular moons made of ice. Makemake. After Haumea is Makemake. Makemake is another dwarf planet located in the Kuiper Belt, around 46 astronomical units or 6.8 billion kilometers away from the Sun on average. It, like the other Kuiper Belt objects, is made of icy and rocky stuff. Makemake is very cold. It has a surface temperature of negative 230 degrees Celsius. Makemake's surface is probably red in color, meaning it is probably mostly covered in tholins. Makemake also shows signs of having a subsurface ocean, just like Pluto and Eris. Makemake has 1 moon, named S/2015 1364721, and nicknamed MK2. It orbits Makemake at a distance of 21,000 kilometers and has a diameter between 175 and 250 kilometers. MK2 is as dark as charcoal. This may be because its gravity is too weak to hold on to any ices to make its surface bright. Eris. Eris is one of the farthest out dwarf planets we have found. It orbits at a distance of 68 astronomical units or 10 billion kilometers away from the Sun on average. Eris is the 2nd largest dwarf planet, only being beaten by Pluto, and it's the most massive TNO we found. Eris was actually the one who demoted Pluto because it was more massive than Pluto, making people start to question what really makes a body considered a planet. Eris is more massive than Pluto by 27% because it is made of heavier stuff. It has a higher percentage of rock than Pluto does. Despite being more massive than Pluto, Eris is still smaller than it by tens of kilometers. This is due to Eris having a higher density because of the higher percentage of rock I talked about earlier. Eris's surface is white. This is due to Eris's surface being completely covered in nitrogen and methane ice like Pluto. But, unlike Pluto, Eris's surface is almost completely white and uniform. This is because Eris is much further away from the Sun than Pluto is, meaning that gases can more easily condense onto snow and cover up any deposits of tholins that form. Even though Eris is much farther away from the Sun than Pluto is, it can still get close enough for some of the ice on its surface to sublimate into an atmosphere. Eris has 1 known moon so far. Its name is Dysnomia. Dysnomia is the 2nd largest known moon of a dwarf planet, only beaten by Charon. It has a diameter of roughly 615 kilometers and spans 24% to 29% of Eris's diameter. In contrast to Eris's bright and reflective white surface, Dysnomia has a very dark surface that reflects 5% of the light that hits it. Eris and Dysnomia is another binary system like Pluto and some of the other dwarf planets in the Kuiper Belt. Like the Pluto and Charon system, Eris and Dysnomia are also tidally locked to each other, meaning they always show the same face to each other. Quoar. Quoar is a ring dwarf planet in the Kuiper Belt. With an average diameter of 1,090 kilometers, it is about half the size of Pluto. I say average because it is actually an elliptical shape like Haumea. We believe that it has this shape not because of a fast rotation like Haumea, but because it used to spin fast and its shape just got frozen in time as Quoar's rotation slowed down. Quoar's average distance from the Sun is 43.7 astronomical units or 6.5 billion kilometers. It takes 289 years to complete one orbit, meanwhile taking 17.7 hours to spin once. Its surface is pretty dark, reflecting only 17% of the light that hits it, which means that its surface is probably devoid of freshwater ice. Quoar also has some interesting things in orbit around it, 2 rings and a moon named Weywhat. Let's start with the rings. The inner ring orbits Quoar at a distance of 2,500 kilometers. Meanwhile, the outer ring orbits at a distance of 4,000 kilometers. This is puzzling because both rings orbit over the distance of Quoar's Roche limit. Also, the outer ring's width isn't uniform and changes in opacity depending on the width of the ring. This ring can get as narrow as 5 kilometers or as wide as 300 kilometers. Now, onto the inner ring. Its width is pretty uniform, a consistent 10 kilometers. It's also very tenuous and is probably very hard to see. Now, onto Weywhat. It is a tiny moon that orbits Quoar at a distance of 13,300 kilometers. It has a diameter of only 170 kilometers, which means it probably isn't rounded by its own gravity. Other than that, nothing else is really known about it, so let's move on. Orcus. Orcus is the dwarf planet in the Kuiper Belt with one large companion named Van. Orcus is estimated to have a size of around 958 kilometers, meanwhile Van has a size of 443 kilometers. Orcus's size is comparable to Sirius's size. It is neutral in color and has a relatively bright featureless surface, which is rich in water ice. Wanna know something about Orcus? Well, I'm gonna say it anyway. Orcus is often referred to as the anti-Pluto. It is often called this because of many reasons. Firstly, it's because when Orcus reaches aphelion, Pluto is close to its perihelion, meaning their orbital phases are almost opposites. Secondly, they're both in the same orbital resonance as each other, that is, the 2-3 orbital resonance with Neptune. And lastly, it's because they both have a large companion half their size, Pluto's being Charon and Orcus's being Van. Speaking of Van, let's talk about it. Van is a binary companion of Orcus. It orbits Orcus at a distance of about 9,000 kilometers. It is believed to have a surface that is devoid of volatiles. Gonggong. Gonggong is a lesser-known dwarf planet. It had the name 2007 OR10, but was finally given the new name Gonggong. The only reason you might have never known about Gonggong is because Gonggong is not actually recognized as a dwarf planet by the IAU, but it is large enough to be considered a dwarf planet by several astronomers. Gonggong has a very elliptical orbit that takes it from 34 astronomical units to 101 astronomical units away from the Sun, or 5.1 billion kilometers to 15 billion kilometers away from the Sun. At around 1,230 kilometers in diameter, Gonggong is pretty large, being similar in size to Pluto's moon Charon. Gonggong is large enough to be rounded by its own gravity and maybe even hold a tenuous atmosphere of methane. Gonggong is reddish in color, likely due to the presence of tholins on its surface. It also has water ice on its surface, which hints at a potential period of cryovolcanic activity in its past. Gonggong has one satellite. Its name is Xiangliu. Xiangliu is estimated to be less than 100 kilometers in diameter. It orbits at a distance of 24,000 kilometers away from Gonggong. Xiangliu is quite strange. It and Gonggong have one of the greatest color differences among all known binary trans-Neptunian objects. Sedna. Sedna is a dwarf planet in the farthest reaches of the solar system. Sedna is believed to have a surface covered in a mixture of the ices of water, methane, and nitrogen, along with tons of tholin deposits that make its surface one of the reddest in the solar system. There are a lot of estimates for the size of Sedna, but most place its diameter close to 1,000 kilometers, which is similar in size to the dwarf planet Ceres and the moon Thetis. Sedna is most famous for its very large and eccentric orbit. This orbit takes Sedna on a wild journey from 76 astronomical units away from the Sun, all the way to 937 astronomical units away from the Sun. This insane orbit is one of the largest, if not the largest, orbit that any dwarf planet has, taking Sedna around 11,400 years just to complete once. Sedna's orbit extends far beyond the Kuiper belt and is one of many other objects with such elliptical orbits. We have some interesting theories that may explain why Sedna is in this very eccentric orbit. The theories range from Sedna being perturbed by other stars in the Sun's Burt cluster, being captured from a nearby wandering star or interstellar space, or even being flung into its present-day orbit by some hypothetical nymph planet lurking somewhere in the far reaches of the solar system. That last one being the most likely and everyone's favorite. Sedna has no moons that we know of so far, so feel free to send him hugs so he isn't lonely. So, that wraps up today's video. I hope you've enjoyed my explanation of the wonderful system we live in. Also, a huge thanks to my friend Cubic. They helped create Ariel and Thea's asset, gather a reference for Shaolinclaw's asset, and gave me some criticism to improve. By the way, this video only covers up some of the basics of the solar system. In reality, the solar system is far more complex and interesting than what I've talked about in this video. And there are plenty more mysteries we still have yet to uncover. Anyway, that's all for today. See you in the next video!